We are looking at elementary statistics, practice test 2 for module 2, chapters 4 and 5. Chapter 4, probability. Chapter 5, discrete probability distribution. We're going to start with a few basic definitions, things you've seen. A simple event has a simple definition, is an outcome or an event that cannot be further broken down into simpler components. A sample space is simply referring to all possible outcomes. A sample space is the set of all possible outcomes or simple events of a probability experiment. If two events are mutually exclusive, the probability that both will occur is 0. Disjoint or mutually exclusive. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. Probability of A intersection B is 0. And the way you write it, you can write it in this fashion or in this fashion or with the intersection symbol using the set theory. The probability of an event is always between 0 and 1, and it can include both 0 as well as 1. And the sum of the probabilities must be 1. What I want to explain about this, the only time it may not be 1 and extremely close to 1, it would be due to round of error. Okay, so it may go to 0.9999, many nines, or 1.0000, many zeros and then 1. It could happen just because of the round of error. That's why you want to keep up with the number of decimals. In fact, if you show fractions, that would be a precise answer in many cases. Sample space for tossing 5 coins would be 2 to the power of 5, which is 32. The way we calculated it is important. The number of outcomes per stage. That means there are 2 outcomes, heads as well as tails. And the number of stages, that means the number of coins, and that gives us 2 to the power of 5 or 32. If we were to write that, we would get H. Look at it, there are 5 H's, and at the end, okay, we have 5 T's. I'm not gonna have enough space to show you the whole thing with a tree diagram, but if you were to get that started with a tree diagram, here's how it looks like for the first stage. And it's a good practice to be consistent by, it's a tree diagram. So this is the first stage or the first toss. So you're going to keep the H at top and T at the bottom. So for the second stage, we do the same thing. We keep the H at top, T at the bottom. And now you're going to continue with that. You have 3 more stages. The number of combinations of n items selected, n at a time. Combination has the following formula. CNR or NCR. Let me show you 3 different methods. This is referring to a combination. This is referring to a combination. And this is where TI calculator uses the notation, the number first, combination, and then R. And the formula is n factorial over R factorial times n minus R factorial. And in a matter of comparison to the permutation, would be the permutation divided by R factorial. So let's go through the process. Remember, in this example, n as well as r are both n. Therefore, n factorial over n factorial times n minus n factorial. Now, this one is 0. Now, 0 factorial. 0 factorial is equal to 1. 0 factorial is equal to 1. So you want to change that to 0. NPR, it's n factorial over n minus r factorial. So for this question, where the number of permutation of n items selected 0 at a time is asked, that means the r value is 0, n factorial over n minus r factorial. Now, of course, what it means is that n times n minus 1 times n minus 2 all the way to n minus r plus 1. If you do that, you get n factorial over n factorial, which results in 1 again. Okay, a quiz consists of 3 true-false questions. How many possible keys do we have? And that's the same format. There are 2 outcomes, true or false, and we have 3 questions, 3 stages, 2 cubed or 8. If we were to write the sample space, this is what we get, again, starting with what we had. If you recall, okay, we can go with true and false here, true and false. So the first, the second, and now the third gives us 8 outcomes. And you want to be consistent. If the top is T, the bottom is F, and continue with the rest of them. It looks like this if you want to go that route. A pizza parlor offers 10 different toppings. You have 10 toppings and you want to pick 4. I hope you realize order is not important, because that's the idea behind the combination. You have n different items, you're choosing R different items, and order is or is not important. If order is important, it becomes a permutation. In this case, order is not important. It doesn't matter which topic, okay, which topping you order first, therefore it becomes a combination, where n is 10 and R is 4 class. So you plug in. We can change this to 6 factorial. Now, of course, you can use a calculator to come up with the answer. If you were to simplify it by hand, here's how it would work. You would keep the 6 factorial and change the 10 to, so this will be changed to 10 times 9, 8, 7, and now we stop at 6 factorial. Remember, 6 factorial means 6 all the way down to 1. The reason we stop, because we can cancel the 2. Again, if you're doing it by hand, and you got to change this to 4 times 3 times 2 times 1. I hope you realize that 4 times 2 equals 8. 9 and 3 cancel each other. We end up with 3 at top. Therefore, again, if we were to do it by hand, 10 times 3 times 7 is left in the numerator, 210. So it can be done by hand. How many 6-letter code words can we make? Of course, there are 26 letters in alphabet. So from 26, we want to pick 6. And we need to recognize this is a permutation, because order is important when you're making up a password, okay, a code. So it's a permutation of 26, choose 6. So that's a permutation formula. We are going to go with permutation 26, pick 6. And this one is, of course, 20 factorial. Notice if we want to go again by hand, 26 all the way to 21. The next one is 20 factorial, which cancels out the denominator. Let me just change the denominator to 20 factorial. In essence, you have a 20 factorial up here, 20 factorial down there, and they cancel each other. And that's the idea behind this. Of course, the number is huge, but the most important part is this, the process. A random sample of 100 people was asked if they were for or against the taxing on rich people. Of 60 males, 45 were in favor. Of all females, 22 were in favor. Write the contingency table and answer the following questions. If one person is selected at random, find the following probabilities. Now, I put these formulas up here for you. Those are conditional probability, because we are going to look into that in this question. So probability of A given B is known as a conditional probability. Is the probability of A intersection B over probability of B. Probability of B intersection B given A is probability of A intersection B over probability of A. It's important to mention a couple of things here before we move on. I'm going to write it and then I'm going to erase it because we need the space. If we were to calculate probability of A intersection B, it is the cross product. This is over 1. If we go this route, probability of A intersection B, and if we go this route, becomes a probability of A given B times the probability of B. And if we go this route, it's probability of a B given A times the probability of A. You have all of these formulas in the formula sheet, so you don't have to memorize the formula, but it is important to understand the formula. The general formula for the intersection is given as such. If A and B are independent, then this changes to probability of A. If independent, then this changes to probability of A, and this changes to probability of B, And simply put, probability of A intersection B becomes the probability of A times the probability of B. So that's important for everybody to know, because again, in this example, we counter that, and this independency plays a huge part in probability theory. So let's see how we move on. I'm going to leave this for a moment. I'm going to make up the table. I'll come back. I'm going to erase this and we continue. Let's come up with the contingency table, and I'm going to show you how to come up with that. It's very simple. So number one, we are looking at males and females, and then for and against. So for and against, whether you put it in the row or column, it doesn't matter, because you're either for or against, okay? Two different columns, males, females. And of course, we will have a total at the end. So the numbers in red are given. So take a look at the grand total, a random sample of 100. So you plug in 100 here. Okay, so that's the first thing. If they were for or against the tax increase of 60 males, so males total is 60, that's what it meant. 45 were in favor, so 45 for it. And by the way, the reason I'm putting M and F and T and A, because later on when we want to calculate, it's easier to go with just the initial, some sort of initial, make up, I know, A, B, C, D, you name it. So far we have number 100, we have number 60, we have number 45 in red. What else do we have? When we continue, it says of all females, that means we don't know this total size for females. 22 were in favor, okay? So under the favor, in front of a female, we have 22, and we don't have the rest of it. So again, we have all those red ones. So how do you come up with 15? 60 minus 45. How do you come up with 67? 45 plus 22, okay? How do you come up with 33? 100 minus 67. So if you come up with 33, you can come up with 15 plus 8. If you have 100 minus 60, you come up with 40, then you come up with 18 and the rest of it. If you have those four numbers in red, you can come up with the rest of it because of this total. So the very first question is asking, this person favors the tax increase. Well, the total people, that would be the sample space, that is your denominator. And out of those, how many are in favor of the tax increase? So the formula would be P of T is N of T over N of S, where S represents the sample space. And so what do we have? 4 total of 67 people. So 67. You've done the table. You don't have to add them up anymore, but just I wanted to show you. Part B, female. Again, total is 100. How many? Total number of females? 40 over 100. Again, P of F is N of F over N of S. It's important to be able to write symbols so your reader can understand exactly what you're doing. Again, you can just go from the table and pick up the numbers. So if you didn't do that, 40 over 100 is fine. And it's a good practice to simplify the fraction. You want to come up with 40 over 100 to show your reader how you arrived at it step by step. And the rest, 2 over 5 is perfect, 0.4 is fine, and you're done. The next one, this person opposes the tax increase on rich people given that the person is a female. So you want to write the following conditional probability. Probability of A given F. So the person opposes. Okay, remember, opposing, we are showing it with A given F. And according to the formulas that we have here, probability of A intersection F over probability of F. And it becomes ultimately the N of A intersection F over N of F. The very first thing I want you to notice in the case of a conditional probability, the total sample size of 100 is no longer there. So one easy way for the sake of calculation, look at the denominator or look at what's after given. This symbol is given. F. How many in this category? F, we have a total of 40. So that is the new sample space. Your original sample space of 100 has shrunk to the sample space for the F group females, so your denominator is F, which is 40. Now, out of those 40, how many are against? So you are basically dealing with this row only. Out of 40, how many are against? 18. Okay, that's why we have the intersection of A and F. So 18 over 40. Of course, we do the simplification if we can, but 18 over 40 is more important than anything else for anyone to see what's going on. The next one, it says This person is a male given that he favors tax increase, okay? So this is the next part. And if you were just to come up with the answer without writing all of this, I just want to make a point. Given, right after given, favors the tax increase. So for tax increase, 6, so you have no longer 100 as your sample space. It has gone down to 67. So take a look at the question. What comes after the given? That's your sample space. Now, 67 is the denominator, therefore. And how many are, this person is a male, how many are in this column? How many are males? 45 out of 67. So if you were just to do the numbers, but if you were to write it more properly, you would write probability of M given T. M stands for males and T stands for tax increase, is the probability of M intersection T over P of T by these formulas. And it changes to N. And the reason it does because you divide the top and the bottom as this number over N of S. I want you to know that. And therefore, the answer is what I mentioned, 45 over 67. So you don't have to, this refers back to this one. And this 100, because total sample space of 100 drops and it becomes N, 45 over 60. This person is a female and favors the tax increase. First and foremost, the moment given is no longer there, you're back to square one and the total sample size of 100. It's important. The sample size only shrinks with the given, with the conditional probability, not otherwise. Therefore, this person is a female and favors tax increase. You are going to write the formula. Probability of F intersection T ultimately becomes N of F intersection T over N of S. And as I said, N of S is 100, F, this row, and T, this column. F, T, they come together, giving us number 20. The next one, this person opposes a tax increase on rich people, or, this is a or statement. This one is a or statement. This one was an and statement. This one, a conditional probability. The or statement, the probability of A union B is probability of A plus probability of B minus the probability of A intersection B. In this case, the probability of A or F, probability of A union F, by that formula becomes probability of A plus probability of F minus the probability of A intersection F. So in other words, if you look at the A, you have 33. If you look at the F, you have 40. But there is something in common between the two, and that has been accounted for 2 times. And that's really the idea that you take off. This number 18 is part of this column. It is also a part of this row. That's why we take off their intersection. It becomes N of A plus N of F minus N of A intersection F over N of S. So as I mentioned, this column, total of 33, this row, total of 40, they have a common number 18. We're going to subtract because it's been accounted for 2 times, and that's your final answer. Are the events females? This is the event. And opposes tax increase. Are they independent? And the next part, are they mutually exclusive? Now, as far as the definition is concerned, for independency, it's simply put, the occurrence of one has no effect on the occurrence of the other. But just the definition is not good enough. You really want to go with the definition that comes from here when I did the cross product, because that is the proof with math. So that is the definition, which really sometimes is hard to understand, and I just mentioned. But the proof is, if you want to look at the 2 events, A and F, is the conditional probability equal to the marginal or simple probability? Probability of A given F, remember, given F. The moment you hear given F, you are in this, dealing with this row, total of 40. And A is against 18, so 18 over 40. Is that equal to probability of A? Well, A deals with the total size of 100 as the denominator, and A would have a total size of 33. These 2 numbers are the same. They are independent. They are not the same. They are dependent. And that's the idea. So that's a proof. By the way, you can look at the probability of F given A and see if it's equal to the probability of F. So one more time, you could look at probability of F given A and ask yourself, is that equal to the probability of F? That's another way. Are they mutually exclusive? Remember, the definition of a mutually exclusive is very simple. Do they have anything in common? And they do, therefore it's not. So probability of A intersection F, look at the A column, look at the F row, because it's 18, 18 out of 100. If it is 0, they are mutually exclusive. Since it's not, they are not mutually exclusive. Find the probability of getting the outcome of tails and 2 when a coin is tossed and a die is rolled, and that's the same thing we were discussing, the concept of independency. The two are assumed to be independent. There's nothing that can say otherwise. Therefore, the probability of A intersection B is simply probability of A times the probability of B. So that would be 1/2 times 1/6. As you know, tails, heads, there are two outcomes, so 1/2. A regular die is 6-sided, so every number has the same probability of 1 out of 6. A box consists of 14 red and 36 blue. Okay, so right away we have total of 50. Okay, total of 50. We're going to select 3 different markers. What is the probability that they are all red? And this is the idea of independency again. If they are independent, first of all, the probability of red would be 14 over 14 plus 36, just to give you an idea. So probability of red is n of r over n of s. And that becomes 14 over 14 plus 36. This is what's important. And of course, don't forget to simplify, but you got to be able to see where the numbers are coming from. Part A, they are independent, just multiply them out. How many of them do we have? 3. This ultimately becomes the same for each case to the power of 3. Probability of all 3 being red, okay, that means their intersection. And because they are independent, just probability of R1 times R2 times R3, each one is 0.28. Do you have to write all of them like that? You don't have to. You get 0.021952 because we are simplifying 7 over 25, this whole thing to the power of 3. Okay. If it gets confusing, you can put a parenthesis, or 0.28. So 0.021952. As far as the number of decimals, you always carry as many as you need, okay? And if you are rounding, remember how the rounding takes place? You go to one more decimal and you make a decision. For example, if I wanted with 3 decimals, I look at 1, 2, 3. I look at the 4th one and I make a decision to change this 1 to 2. So you want to be very careful with your rounding, otherwise it will be wrong. Part B says, okay, we're going to do the same thing, but this time is without a replacement. The first one, and we are interested in the probability of all red. So probability of R3 given R1 intersection R2. This is R2, okay? And so what do we do here? In this case, understand that we have 14 red and 50 total. Now 14 over 50 for one of them. But the next one, everything goes down by 1. We no longer have 50, we have 49 total, and 14 goes down to 13. The next one, the total of 50 goes down to 49, it goes down to 48. 14, the original size of red, goes to 13, goes to 12. So originally we have 14 reds, 50 total. Because it's without replacement, this 50 goes down to 49, this 14 goes to 13. The next one, 49 goes down to 48, 13 goes down to 12. This is the precise methodology, and you do it with a bunch of decimals and you come up with the answer. Now, it's important to see how this is done also with the tree diagram. You want to draw a tree diagram. By the way, the second method, probability of all 3 red would be n of all possible reds over n of s. We have 14, we want to choose 3, and it's a combination. Order is not important. The total size, combination of 50, choose 3. We can choose from 50, we choose 3, but we want to choose red. From 14, we choose 3. That would be the numerator. that would be n of s to the number. You can try that and you see you come up with the same answer. In more complicated cases, this is the methodology to go. What I want you to pay attention to is the tree diagram. Here's what happens. You may be asked to write probabilities. So you would write 14 out of 50, and for blue would be 36 out of 50. Again, I don't want to simplify it. There's a reason. You see it in a moment. If they ask you for the numbers, and it may be easier to write the numbers, you just write 14 here and 36 here. When we go to the next stage, again, we are going to keep the same thing at top. It's red and blue. So if this is red, this is blue. Okay, so this is red, this is blue, and so on and so forth. Okay, so what happens now? 14 out of 50, 13 out of 49, or just 13, and this is 12 out of 48, or just 12. Now notice, for example, this branch is blue. Because we are here, and then here, and then here, no blue has been gone. So this one gives you still all 36 blue. So 36 out of 48. If we look at this one, it's 36 out of 49. Now, if we go to this branch, now this one, for the red, we have it all intact, all 14 are there, but the blue from 36 goes down to 35 in this branch. So first we have 36, because this is blue, now it's 35. And you can figure out the last stage here, the blue from 36 to 35 to 34. But the red, it is still intact, total of 14. So that's how it works. Here's the next one. If the probability of winning is given as 5 over 12, what is the probability of losing? What are odds against winning, so on and so forth. If the payoff odd is 6 to 1, how much profit do you make if you bet $10? All right, so complementary event, first and foremost, probability of A naught or A complement, or sometimes they call it A prime or A bar, is 1 minus probability of A. So if the probability of winning is given 5 over 12, then probability of losing would be 1 minus that. So 1 minus 5 over 12, common denominator is 12. 12 minus 5 is 7 over 12. Definition of a odds against would be probability of a complement over the probability of an event. So the actual odds against event A, O represents the odds, against is A complement, is probability of A complement over the probability of A. It's important to see the formula. Again, it's given, you have it in your formulation. And we normally put them as A to B, okay, or A colon B, and they are in integer format. So with that being the case, we want the odds against winning. So we are going to write the formula. Odds against winning, that means odds for losing. That means probability of W naught, or probability of losing, over the probability of winning according to this formula. So 7 over 12 over 5 over 12. I hope you realize the complex fraction, 12 cancel each other, 7 over 5. You can leave it like that, or you write it as 7 to 5. If the payoff odds is 6 to 1, how much profit do we make? Basically, you multiply this ratio. Let's say it's 6 to 2, that means 3, okay? 6 to this number, this is a fraction. Whatever this fraction is times 10. So let me explain a couple of things. First of all, the payoff odds against an event is net profit divided by the amount bet. So payoff odds is net profit over the amount bet. So net profit would be the product of these two. Okay, we are looking at the cross product. So payoff odds against an event is 6 to 1. The amount of bet is whatever in this case happened to be $10, and that means 60. Now, what I want to explain here is that it's important not to mix this up with when you play Lotto, for example. If you're playing something, let's say, like a blackjack, which normally pays 1 to 1 as far as the odds concerned, unless you get a blackjack, the amount of bet that you have, it's in front of you and it's not going to go away. If you win, they give you the same amount. So that's why the same amount is your net profit. Whereas when you buy a ticket, okay, if you bought it for $2, even if you win $100, $2 is gone. Number 16, A classical counting problem is to determine the number of different ways that the letters of personnel can be arranged. Find that number. So first, a quick reminder of permutations, and in this case, a distinguishable permutation when some letters are identical to others. Okay, the formula is n factorial over n1 factorial times n2 factorial, so on and so forth. The number of different permutations or their counts when n items are available and all n items are selected without replacement, but some of them are identical. So we are going to look at the number of letters and what's in common. N, there are 9. Okay, we have total of 9. Then P, there is 1. E, there is 2. R equal, there's only 1, and so on and so forth. So you got to count that. And now you're going to follow this and plug it in. So when you do that, the numerator is 9 factorial, and the denominator, you put all of them with the factor, or anything with 1, even if you don't, doesn't matter because that becomes 1. And so simplification will give us the following answer. Here's the next question. When two different people are randomly selected from those in your class, find the indicated probability. Assume birthdays occurs on the same day of the week with equal frequencies. What is the probability that two people are born on the same day of the week? The probability that two people are both born on Monday. And I hope you can see and distinguish between the two. In the first case, any day is fine for the first person. And then the second person must be born on the same day. Whereas here, we want one of them on Monday and the second one also on Monday, or any other day, it works out the same. So that would be the difference between the two, in which case no particular day is specified for the first one. So the second person born on the same day as the first one is 1/7. And so basically that's the answer, because we want them to have the same birthday. And for the first one, it really doesn't matter. The first one has 7 choices out of how many? 7. But then it's the second one that doesn't have any choice. It has to be the same day as the first person. So the first person has a choice. That's 1 or 100% or 7/7. The second doesn't. Their product is 1/7. However, in this case, each one must be born on Monday, a specific day of the week. It's 1 out of 7. So each one has a probability of 1/7, and their product is 1/49. So it's important to distinguish among those, the two questions. How many different auto license plates are possible if we want to do the following? We want 2 letters followed by 4 numbers. The very first thing is that there are 6 spots. I want you to see that there are 6 spots. 2 letters follows by 4 numbers. So for example, here you would put what? Letters, so 26. The second one, I don't see any restriction. So again, I put 26. And then numbers, how many numbers? From 0 to 9, there are 10 digits. So I can put 10 here, no restrictions, and I keep on going. Therefore, it's 26 squared times 10 to the power of 4. I'm assuming everybody can do the math. I just want to show you how you arrive at the answer and the reason for that. And of course, you can put it into a calculator. Now, we're looking at the same 6 spots, 3 letters, no repeat. So that means if the first one is 26, the second one is 25, the next one is 24. It goes down because we can't repeat it. Followed by 3 numbers, no restriction, so each one can be 10. So you have 26, 25, 24, and the last 3, each one is 10, 10 cubed. Again, the process is important. 4 letters, no restriction, so all of them are 26. And then 2 numbers we can't repeat. So this one is 10, but this one goes down and it becomes 9. So the first 4, 26 to the power of 4, and the last 2, 10 and 9. Now we want 4 places. So the 6 spots is gone. We want 4 spots. So the very first thing, maybe you want to write 1, 2, 3, 4 spots. Each character is either a letter or a number. Well, we have 26 plus 10, 36 characters, and each one can go here. There is no restrictions. So there are 36 characters, 36, 36. So it's 36 to the power of 4. By the way, when it comes to combination, factorial, permutation, you can use a TI calculator. I have the command here just to let you know it can make your life easy, but it is important to understand the process and what happens. So we have in a first grade school class, we have 10 girls and 8 boys. In how many ways can we choose the following? So let's go with the first one. The students finish first, second, and third in a foot race. So, and assume no ties. Well, you have total of 10 plus 8, 18 students. Order matters. You're picking how many? First, second, third. You're picking 3. It's a permutation of 18. Pick 3. So you can go with the permutation formula. You can say 18, 17, 16. However, either way gives you the same answer. Now, in the second case, the girls finish first and second in a geography contest. Now, we are dealing with how many? Total of 10 now. And how many places? 2 places, and order is important. Okay, so again, it's a permutation, 10, choose 2. Now, 3 boys be selected for lunch. Out of 8, we want to pick 3. Order is not important, combination. So combination of 8, pick 3. Again, I'm hoping everybody can see the concept as to why it's a combination, why it's a permutation. The rest is very simple. 6 students be selected for a team, any team, hockey team, okay? So we have what? Total of 10 plus 8, 18, and we want to use 6. That means order is not important. That's a combination. 5 students. How are we going to select them? 3 boys, so that's 1 spot, and then 2 girls. Okay, 3 boys out of 8. There is no restriction. Okay, order is not important. So combination of 8, choose 3. Done. 2 girls out of 10, 2. It's a combination again because order is not important. And then you, by the way, for this one, I'm showing you if you use a TI calculator, you put 18 first, then NCR, then number 6, and it gives you the same answer, okay? This is in case as an example. Now, order is not important. Combination of 8, choose 3 times combination of 10, choose 2. So in essence, this one uses a combination here, this one uses a combination here, their product is the answer. And then finally, 4 girls be selected for a field trip. Out of how many? 10. We want to choose 4. Nothing is specified. Order is not important. Therefore, it's a combination. So combination of 10, choose 4. We are given a table which represents X number of girls, 0, 1, 2, 3, and P of X is the probability, okay, of 3 birds. Does it describe a probability distribution? What is the random variable? What are its possible values, and or its value numerical? Is this describing a probability? For this to be a probability, this must be numerical. It is. The probability in each case must be between 0 and 1. It is. And they must add up to 1. Those are the main things that you want to be careful of. So the variable X, which is the number of girls, okay, 0, 1, 2, 3, is a numerical random variable. And they are associated with probabilities, okay. So the next one is that the summation is 1. So each one, and of course, each value is between 0. There are really different criteria. These are the main criteria. Number 1, make sure that each one is between 0 and 1. Can it be 0? Yes. Can it be 1? Yes. But it can't go yet. Number 2, make sure they add up to 1. By the way, this is where I discussed that you may end up with the situation where the sum is not exactly equal to 1, but it's extremely close due to round off error. I'm going to repeat because this is important. If this is 1.000000001, that's okay because it's just due to round off error. Or if it's 0.999, many nines. But if it's 0.99, that may not be good enough, or if it's 1.1, is not good enough, okay? And of course, the variable x, which is the number of gears in 3 bits, what can it be? 0, 1, 2, 3. They are all numerical random variables, okay? And they're associated with probability. So that explains that. In a game, you pay 60 cents to select a 4-digit number. If you win by selecting the 4-digit number, you collect $3,000. This is what I mean when I said, you play Lotto versus a blackjack and the concept of a payoff. So when you pay 60 cents, your 60 cents is gone. You bought it, gone. Whether you win or lose, it makes no difference. The 60 cents is gone. And that's the idea. If we win, we collect $3,000. How many different selections are possible? It's important to know that we are looking at 4 digits. There is no restrictions given. Remember, the digits is from 0 to 9. That means 10 numbers. So there are 4 spots. That's important to see. There are 4 spots. That means we have 1, 2, 3, 4 spots. And that means 10 to the power of 4, and that means 10,000. And at the top, by the way, I have the formulas. Mu is summation of x p of x. Sigma squared is summation of x squared p of x minus mu squared. This is a second method to write that. And so let's do that. And the number of digits is 10. Why is that? Because we go from 0 to 9. There are 10 possible numbers in 4 places. We have 10 to the power of 4 or 10,000 ways to pick. What is the probability of winning? There's only one possibility of winning $3,000, so 1 out of 10,000. So what if we win? If we win, what is our net profit? Well, we win $3,000, but we paid 60 cents, so minus 60 cents. And that's important to understand. The net profit is the money that we gained minus the investment. Granted, the investment 0.6 compared to 3,000 is peanuts, yet you have to write that. Now write the probability distribution of net profit if you win. The probability distribution, it's simply putting the x as well as p of x. That's it. So we are looking at part D. The winner, 3,000. There will be how many? 1 winner. And the rest, 10,000 minus 1, 9,999 will lose. And the total is 10,000. Now, net gain for the winner is this amount. We just calculated, right? But what about the rest? The rest would be 60 cents with a negative sign. I can't emphasize the importance of writing this properly, including the sign, negative 0.6. So what is the probability? What is the probability of x? For this one is 1 out of 10,000. For this one is the rest, 1 minus that. So 9,999 over 10,000. And as always, they must add up. These two must add up to 1, and they do. This is it for part D. It says, write the probability distribution. This is the probability distribution, okay? X is numerical, okay? X is a number. Probability is between 0 and 1. They add up to 1 or 100%. So everything that we discussed in the previous example, it checks. Now we want to find the expected value, and more importantly, what does it mean? So to find the expected value, okay, mu is summation of x px. So let's multiply x by p of x. Let's multiply this column by this column, this number by this number, this number by this number. Now this one is for the sake of calculating the variance. It hasn't been asked, but this is what really we want. I figure it's not a bad idea to see what happens here. So the product of these two gives us this number. The product of these two gives us this number. Now, this is extremely important. But by the way, how do we come up with that x squared p of x? Square this number. It's almost 3,000. It's not 2,999.40. Square it times 0.0001. You get this one. Square this number, which becomes positive, by the way, times this number. And you write it here. That's the summation of x squared p of x, okay? We're going to get there. That is really not what the question is asking us, but I thought at least you have seen the calculation here. Now, summation of x, p of x is mu, and it's negative 0.3. And this is extremely important to understand. Mu is this amount, whereas sigma squared is this amount minus mu squared, and sigma is the square root of that, by the way, which is sigma squared is the variance and sigma is the standard deviation. Well, we can calculate that, but really, even if we don't, this really is telling everyone, and that's okay, the interpretation. Everyone who plays on the average gains this much. How much? Negative 0.3. That means what? Everybody loses 30 cents on the average. Everyone loses 30 cents on the average. So mu is negative 0.3. Sigma is this formula. Look at this formula, put it under the radical. You have this one minus mu squared. You're going to minus mu squared. You calculate that. And they didn't ask for this one. I just added. Okay, it's not. What matters is the first part. On average, a player, all players, including the one who wins, all players, okay, they lose. So a player loses how much? 30 cents on average. That means per ticket. What does it really mean? I want to make sure everybody understands the meaning of this and the importance and the power of this statement. And that is, for every ticket that they sell, they collect 30 cents from the people. So the company offering this is, on the average, collecting 30 cents from each player. Every ticket brings them some money. How much? 30 cents. And that's important for everybody to know. A pharmaceutical company receives large shipments of aspirin tablets. This is called the concept of quality control. The acceptance sampling plan is to randomly select and test 24 tablets. So we have a huge shipment and we randomly select 24 of them. The entire shipment is accepted if at most 2 tablets do not meet the required specs. If a particular shipment of thousands of aspirin tablets actually has a 5% rate of defects, what is the probability that this whole shipment will be accepted? Okay, so let's just quickly recap what's happening. This is a quality control. They receive a huge shipment. They can't check every tablet. So what do? They have decided that if they randomly pick 24, and I can't emphasize the importance of randomly because otherwise it defeats the purpose of doing this test. You randomly pick 24, and if 2 of them at most is no good, you say the whole shipment is out and they have to take it back. That's the concept they have come up with. And they know there's a 5% rate of defect. They want to calculate that. So we are going with BD, binomial distribution. And in short, binomial distribution, really you have 2 outcomes. Okay, N is the number of trials. And the 2 outcomes, good, bad, tails, heads, okay, defect, or it has no defect, things of that nature. Again, the formula is, in the formula sheet, P of x equals n factorial over n minus x factorial times x factorial, P to the power of x, Q to the power of n minus x. Mu is NP and sigma is square root of NPQ. Those are the formulas that you need. So this is a binomial distribution. So if you're claiming this is a binomial distribution, you always need to give 2 things. What is your N? What is your P? N, in this case, is 24. P is 5% or 0.05. Remember, P refers to the probability of success. Success doesn't necessarily mean something positive. That's important to know. So if we want to go with this formula, we are going to replace the P with 0.05. We're going to replace the N with 24. And everybody remembers that Q is 1 minus P, or 0.95. By the way, these are the probability distribution properties. N identical or fixed number of trials. Each repetition of the experiment. Each has only 2 categories of outcomes. Probability is constant and they are independent. trials. So with that being the case, here's the formula that we are going to use, where P is 0.05, Q is 1 minus that 0.95, and that is the formula we're going to use by replacing the N with 24, replacing the P with 0.05, and Q with this. And now what happens? Let's go back and read. The entire shipment is accepted if at most 2 tablets do not meet. So probability of at most 2 tablets, that means probability of X less than or equal to 2. So when X is 0, you plug in 0 instead of X you calculated. When it's 1, you plug in, you calculated. When it's 2, you plug in, you calculated. So you want the probability of X equals 0 plus the probability of X equals 1 plus the probability of X equals 2. And I'm assuming everybody can do that. By the way, I put here X equals 0, and then I didn't put X here for short, probability of 1, probability of 2. And they add up to 0.884, which of course means 88.4%. They didn't ask for a percent. That's good enough. Now, if you want to go with this formula, you have to plug in 0 calculated, 1 calculated, 2 calculated, add them up. You can also use, after you understand the concept, after you write, it's a binomial distribution, after you write this formula, then you can use this simple, and it's in posted, okay, in the formula sheet. Also, it's given in the PowerPoints. So second variable is binomial PDF, enter NPX. And if you enter NP only, that gives the probability from 0 to N. And if you're using binomial CDF, it gives the sum of them. So take a look at what we do. We put binomial CDF. The number is 24, probability is 0.05. When we put X equals 2, that means from 0 to 2. It calculates, and notice the answer, of course, with a lot more decimals. So we have the same answer. It is known that 90% of managers of all companies suffer from job-related stress. What is the probability that in a sample of 10 managers, exactly 8 suffer from job-related stress, so on and so on? So the very first thing you need to recognize what type of a distribution we have, and this is a binomial distribution. Why is that? There are only 2 outcomes. Either they have stress or they don't. So what is N? We are looking at N equals 10. What is P? We are looking at P equals 0.9. So it's a binomial distribution, N is 10, P equals 0.9. Again, P doesn't have to represent something positive. In this case, if P is 0.9, that means Q is 1 minus that. And for this formula, we're going to replace the N with 10, okay, and P with 0.9, and Q 1 minus 0.9, which is 0.1. So P is 0.9, Q is 0.1, plug it in. So this is your formula now. Probability of X is 10 factorial over 10 minus X factorial times X factorial times, now P is replaced with 0.9, Q with 0.9. Practically you're done. So for part A, all you have to do, replace the X with 8. So probability of 8, replace the X with 8. At most 2 suffer from job-related stress. At most 2. The same as the previous page, X is less than or equal to 2. By the way, if you go with the TI calculator, you get to the answer. Notice binomial PDF, 10.98, here's the answer. At most 2, you need to calculate the 0, 1, and 2 and add them up. Okay, 0, 1, 2. How do you do that? In this formula, replace the X with 0, replace the X with 1, replace the X with 2, add them up, and it's almost 0. But notice I put a lot of decimals. I want to make a point. It is not 0. It's extremely close to 0. And you can calculate it. Again, I'm showing you one by one calculation. You don't have to do that. I'm showing you in case you wanted to do it by hand. What's important for you is, again, you want to write this for your reader. You want to write this for your reader. You want to write this for your reader, and then you can put the answer. okay? Because you're telling them, you know it's a binomial distribution, you know what's n, you know what's p, you know how to calculate the q, all of the above. And you know what to do, and at the end, you can use a calculator now. Just as before, just CDF 10.9, it's binomial CDF. And when you plug in, you get this number. Now, it's important to know this is given in scientific notation, and sadly, some students don't know scientific notation. So it's important that you recognize when it's a scientific notation, how to deal with that, okay? So that means 10 to the power of -7. So you want to pay attention to that and come up with the proper answer accordingly. Next, at least 3 suffer. That means probability of x larger than or equal to 3. And that means 3 all the way to 10. That's the meaning of it. Again, I'm writing the meaning. Probability of x larger than or equal to 3 means probability of 3, 4, so on and so forth, because that's the meaning of x larger than or equal to 3. However, if you look at part B, probability of x less than or equal to 2, I hope you realize there are complementary events. In other words, probability of, take a look at this, probability of x larger than or equal to 3 is the same as 1 minus probability of x less than or equal to 2. They are the same. Instead of calculating from 3 to n, and by the way, n happened to be 10, it's not a big deal, but what about n being 300? You definitely don't want to calculate that. So instead, you calculate the ones before that and you subtract it from 1, because the total probability is 1. So this is the complementary event you're going to use. And when we do that, it's 1 minus the previous one, which is very close to 1. Again, the numbers are a little bit off. That's why I chose to go with many decimals. So having said that, what is the next part? We want to find the expected value. Well, to find the expected value, mu or E of x is n times p. Find the standard deviation, sigma is square root of npq. So we multiply this by q and we take a root. So this is sigma squared. Now take a root. Very straightforward. All of these formulas in your formula sheet you should be comfortable with. Finally, would it be unusual to claim that at most 7 managers from this sample suffer from job-related stress? All you have to do, just go with mu plus minus 2 sigma. I hope you remember this, the empirical rule, mu plus minus 2 sigma, okay? The range rule of thumb. So mu is 9 minus 2 times this number, and then mu is minus, this is number 9, add and subtract, and between 7.1 and 10.89. Is this number, going back to this number, in between? If it is, usual. If it's not, it's unusual. Although it's extremely close, but it is not in between. This means it's not an element of, this is in set theory, not an element of. It's not in between, therefore unusual, okay? Not in between, therefore unusual. Find the probability of couple having at least 1 girl among 3 children. The probability, the assumption in biology is that the probability is the same, 50% or 1/2 for both cases, okay? So we want the probability of at least 1 is 1 minus the probability of a none. Noticing this one, so 1 minus none. When we say having at least 1, none, that means all of them are what? The other gender. All of them are boys. Okay, 1/2. And because the probability is 1/2, and we are assuming independency, by the way, so 1/2 to the 3rd power, so 1 minus that. So the probability is 7 out of 8. You can also do the tree diagram to see that. By the tree diagram, I mean you put the first one, let's say B and G, and then you finish it off. Here's the second method using the binomial distribution, where we have 3 children, n is 3 and p is 0.5. Now, at least 1, that means x is larger than or equal to 1. Now, p happened to be 0.5, so is q, 1 minus that. We want x larger than or equal to 1. That means 1, 2, 3. And so you want the probability of 1 plus the probability of 2 plus the probability of 3 using a binomial distribution, where n is 3, p is 0.5, so is q. You can plug in 1, 2, 3 and calculate and add them up, or just it's easier to go with the complementary event because it's easier to calculate only one of them, plug in 0, evaluate, and 1 minus that. So this is the formula. Okay, as I mentioned, n is 3, p 0.5, q is 0.5. By the way, they add up to 0.5 to the third power because they are identical. The base is the same. And now just plug in 0, subtract from 1, and that gives you the same answer. Whether you go with this method or the other method makes no difference. If an alarm clock has a 0.9 probability of working on any given morning, what is the probability that it will not work? What is the probability that 2 such alarm clocks will not work? What is the probability of being awakened if you have 2 such alarm clocks? The assumption is if it works, you wake up, okay? So what is the probability that it will not work? If the probability of working is 0.9, the probability of not working is the complementary event, and it's 1 minus that. So there's a 90% chance it works. There's a 10% chance it will not work. What is the probability that 2 such alarm clocks will not work? We are assuming independency. There is no reason to assume dependency unless one condition happens, and that is they're plugged into the same power outlet and somehow power goes out. That's the only time that then it will be they will be dependent. Other than that, independency. And so you follow that probability of W1 is the first one working, and W1 not, probability of an alarm not working, okay? What is the probability that 2 such alarm clocks will not work? It's very simple. They are independent. Each one has a 10% chance, so 0.1 times 0.1. If we want to write it properly, probability of W1 not intersection W2 not, okay, of the first and second alarm not working, and we have to multiply them because we are assuming independency. So 0.1 times 0.1 is the answer. Again, as far as explaining it with the formulas, that really makes a difference. So there's a 1% chance that 2 such alarm clocks will not work. The idea is the idea of quality control. To be on the safe side, if you have 2 alarm clocks, the probability of 10% not working is horrible here. Going to 2, it takes it down to 1%. Imagine if you go to the third one, then you multiply by another 0.1 and it goes to 0.001, 1 out of 1,000. And that's the idea of quality control. They use that for example, jet engines also to make sure passengers get home safe. So the engines work independently. What is the probability of being awakened if you have 2 such alarm clocks? There's a 1% chance they both fail, so the assumption is 99% that it won't, and therefore there's a 99% chance we wake up. So this is method 1. 1 minus part B gives us 0.99, so there's a 99% chance. Here's the second method. We can use the addition method. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. And remember, in this case, awakening, that means if it's working. So probability of working is important to us, which is 0.9. So each one is 0.9 in essence, okay? So we are looking at probability of W1 union W2, okay? So we are going to replace each one with 0.9. So we get 0.9 plus 0.9 minus the product 0.9 times 0.9. Again, the reason we multiply because of independency, and that gives us the answer the same as before. Finally, the third method, you can use the binomial method distribution. There are 2 alarm clocks, n is 2. The probability of working is 0.9. Here's the probability that we are going to use, and we are going to replace the n with 2, p with 0.9, and q with 1 minus that, or 0.1. Now, We want the probability of what? X larger than or equal to 1. As long as one of them works, we wake up. So probability of X larger than or equal to 1. That means probability of X equals 1 plus probability of X equals 2. Instead, 1 minus probability of 0. So replace the X with 0, calculate it, subtract from 1. That would be a tad faster. And when you do that, you get absolutely the same answer. So there are 3 different methods to solve this question.